Hi guys, welcome back. Today we're gonna learn about the average value theorem. Lucky for you, this is a really easy and quick one. I know the last 2 days weren't so great. You probably had a lot of homework. Today will be very simple. You'll like this one. This is a piece of cake. And that way, if you didn't finish quite all of your homework, you can probably finish it all up today. Okay, average value theorem. Very easy. Let's say that I make this thing up. I make up some function that represents the temperature in our classroom at any given time. Well, first, think about that. Does the temperature ever not exist? Is it possible for there to be no temperature at any given time? Hopefully you said no. So therefore, the temperature in this room is a continuous function. And I want to find the average temperature. Well, before we do that, let's think of something a little easier. If I asked you for the average of all of your test grades, well, that's easy because there's a defined number of test grades. So let's say you had 5 tests. You know what you do. To get the average, you'd add them all up and then divide by 5. Easy. So to find an average, you add up all the tests and divide by the number of tests. Well, we're going to do the same thing. To find the average temperature in my classroom during my 8-hour workday, I'm going to first add up all of the temperatures. Well, the temperatures are constant. They're always changing. There's a temperature right now, and then there's a temperature right now. There's always a possible new temperature. It's a continuous thing that's possibly changing every single second. So how do I add up a continuous function like that? Okay, well, I want you to think about it. I want to take the temperature function, f of t, and I want you to somehow add all the possible temperatures from t of 0 to t of 8. Well, what's a mathematical symbol that you've learned that means add them all up? Other than a plus sign. Other than a sigma. Hopefully somebody, I have no idea, hopefully somebody said the integral. So the integral is a summation symbol. It's going to add up all of the temperatures from t of 0 to t of 8. So that's adding up all the temperatures. But to get an average, I don't just add them. I have to add them all up, and then I have to divide by the number of temperatures. So to find the average temperature, I have to add them all up and then divide by, what do you think? Divide by 8, this minus this. And that would give me the average temperature in this classroom. So this is called the average value theorem. Here it is formally. Okay. To find the average, it has to be continuous. Okay. We just do the integral, which adds up all of these things, and then divide by the number of numbers. Okay, I'll give you a minute to write that down, but I don't think I would write f of c. I don't like that formal stuff. I would just write average equals this. Okay, make a note. Please make a note. When you do this, like this problem that we just did with average temperatures, what you get is the average temperature. You don't find time. We didn't find when it will hit that average temperature. That's important to know. Every time you do the average value theorem, you're actually getting a y coordinate. Sometimes they ask instead, when does it reach the average, which is like your x coordinate or your t, time. So look out for that. Make sure when you do the formula, you understand that you're finding the average temperature, the average y coordinate. Okay, so you might want to write over here, this is always a y coordinate. Sometimes they then ask when will it reach that average, and that means you just have to do a little bit more algebra. Okay, hopefully you've had enough time to write that down. Pause if you need to, and let's just do one really easy example. Super quick lesson today. Okay, take a minute to read this. The level of air pollution X miles from a tire factory. Do you think that's a realistic problem in the world? Do you think people who live near that tire factory could possibly care about the level of air pollution depending on how close they are to the factory? Sure. And these formulas, I have no idea where this one came from, but lots of times I used to know someone who wrote math textbooks. I know, I'm super exciting. But he would get formulas sent to him from all over, realistic word problems with real formulas. So I don't know, but this could actually be legit. Don't know though. Regardless, this represents the level of air pollution, okay? And the X represents how far away you are from the tire factory. So the question, what is the average level of pollution between 10 and 20 miles from the factory? Show your setup. Make sure you get that right first. So everybody should write it down right now on your papers, what you think the setup is for finding the average pollution between 10 and 20 miles from the factory. Okay, let's check what you did. If you want to get credit for this on the AP exam, don't take extra risks. I can actually write it like this. I want the total amount of pollution from 10 to 20 of, I'm not even going to write all this stuff. I'm just going to write of L of X. They know what it is. They called it that. Now that's going to add up all the different levels of pollution. So now I still need to divide by 1 or multiply by 1 over 20 minus 10, which is 10. That's the same as dividing by 10. So this would give me the average level of air pollution. Okay, take a minute to actually put that in your calculator, hit pause, and when everybody's ready, I'll have the answer displayed. Okay, hopefully I put this in my calculator correctly. I have the answer hiding underneath my PowerPoint here, but I don't have the PowerPoint running, so I don't know what's hiding down there. So I just put it into my calculator real quick, but it could be wrong. You guys better discuss it. I got 0.238. I don't know what the units are because it's level of air pollution, so I don't know how I measure that. But I got 0.238. Hopefully you did too. If the whole class disagrees with me, then I'm probably wrong. All right, pause if you want to. I'm going to move on to one more example. Oh, before I do, this is the average level of pollution. What if instead of asking for the average level of pollution, what if they instead asked when or how far out from the factory do you have to be to reach that average? How far out from the factory do you have to live to reach this average? Well, that would mean they're asking for X. You simply take your answer for L, put that here, and algebraically solve for X, which this problem would be tricky. You would just have to solve it with a calculator and graph it. Set it equal to 0, look for the X-intercepts. Okay, moving on. This next one's real boring, no real world application at all. Okay, find the average value of the function, and this is the function right there. Find the average value of the function on the interval from 0 to 3. And then, at what point or points in the interval does the function assume its average value? Okay, so think about that for a little while. Here's the average value formula. At what point in the interval does the function assume its average value? So go ahead and apply the average value theorem, okay? On the interval from 0 to 3 means I want the average from 0 to 3 of f of x. Well, that's the sum of all the different y coordinates, then divided by 3, or multiplying by 1 over 3. This will give me the average. Okay, this is one that I think we could work out by hand very, very easily. That is easily done by hand. So either work it out by hand or plug it into your calculator. Okay, after you work it out by hand or in your calculator, I'm going to have to work it out by hand. It's bugging me. 4 minus x squared. Okay, real quick then. Let's see if it's terrible or not. We have 1/3. This is going to be 4x minus x cubed over 3, evaluated from 0 to 3. Plugging in the 3, I get 4 times 3, which is 12, minus 27 over 3, which is 9. Minus plugging in the 0, you get zeros. So hey, that was easy. 3 times 1/3, which is big fat 1. Okay, now read the question again. At what point or points in the interval does the function assume its average value? They're asking when does it reach that average value? And you know that this is an upside down parabola. It's a negative x squared. It's an upside down parabola. If I cut it between 0 and 3, let's say this is x of 0, this is x of 3, what is the average height? Well, the average height of that parabola is 1. What they want to know, though, is when does it reach that height? So for what x coordinate will it reach that average height? Okay, so all you got to do is take your formula here. This guy, sorry, messed me up. Take the original formula, f of x equals 4 minus x squared. I want to know when will this equal that height. Plug in a 1 right here. Okay? So solve for x squared. Subtract 4, you get negative 3 equals negative x squared. So x squared equals 3, and x will equal plus or minus the square root of 3. Two different answers, but actually it's not plus or minus because we're only looking on the interval between 0 and 3, so we would actually only give the positive 1. So it's the square root of 3. So if this is x of 0 and this is an x of 3, the average height from here to here is 1. And when does it reach that height? At square root of 3. Okay? The average height is 1. The x coordinate is the square root of 3. Square root of 3, however, is the answer to the question that they asked. Okay, stop, pause, ask questions, talk to each other. Hopefully you got that. I swear this one's really, really easy. Don't let it overwhelm you. Good luck with your homework. Here is your homework. It's very, very short because I know you've gotten a lot the last couple nights. All right, good luck. See ya.